There's ship shape now, I think. All right. It's broadcasting, it's recording for later. Is there anybody down on the coast?
Yes.
Okay, great. The room's kind of dark, so. Oh yeah, I see you there on the second row. All right, great. So, we didn't meet last Thursday because of fall break, and we have one more break that will affect the class, and that's Thanksgiving, the Thursday of Thanksgiving. Technically, we don't get out for the whole week, right? So we still have a meeting. We still have a meeting on that Tuesday. So there's a little over a month left of class. And today what we're going to talk about is using vector layers. We've actually used some vector layers without really saying that we've used vector layers, and that was when we made the circle that got bigger and smaller. Okay. I don't know if you remember that. We centered a circle on university and we made it bigger. Technically, that was a vector layer. It was a circle vector layer. When I say vector, what does that mean? A vector layer. Right, we use the term vector to mean point, line, or polygon. That's probably what you were going to say on the coast, and that's correct. Now, the Philadelphia neighborhoods, for example. Now, those are drawn or derived from vector data, okay? So why am I not referring to that as a vector layer? And I'm not referring to that. That's something else, okay? So basically, there are two methods that a web map can use to show your vector data. One method is for the server to handle the drawing, the rasterization of that layer. And that's what we've been doing. So we have that's what a web mapping service does, is it takes layers and it turns them into images that are then transferred back and forth between the server and the client. So thus far, when we've shown examples in this class, we've been relying on map services that basically in the background what they're doing is taking a bounding box, making a request, getting an image back, and then just plopping that image onto the map for you. Okay, plopping is not a technical term. Placing that image onto the map for you. Okay, so we're using vector data, but what we've actually placed on our map is not a point or a line or a polygon. It's an image. It's a representation of that point, line, or polygon. Okay. So what we're going to talk about today is the second method. When I have some data, one option is to ask the server or the web server for the data itself, and I get that data, and I take that data, and the web browser then handles the display of that data. It puts it on the map. Okay, now the problem, what's a common vector data format that we use for GIS? Shapefile, that's right. That's still a very common data format for a vector shapefile. I mean, for vector data is a shapefile. It's widely adopted. It's technically an open standard now. ESRI has open sourced it, so anybody could write a program that will. Anybody can write a program that will allow their program to ingest and display shapefiles. There are other formats out there. Lots of them have been created by ESRI, like the GeoDatabase, and then one that Google used starting a few years back was KML, keyhole markup language. It's mostly a vector file format. You actually can use KML to throw an image on top of Google Earth if you wanted to, a georeferenced image, but you're still giving it some coordinate pairs to bound the KML. All right, now, with the exception of KML, those other two formats that I talked about, the file geodatabase, shapefiles, those are formats that the web, they aren't very good for sharing data in a browser. A web browser can read things like text and images. It can't read binary files very well. It needs a server, and that may change in the future. But right now, browsers aren't good at reading binary files. They need a text-based format. And KML is a good candidate. However, and that was used for a long time to display data on web maps. However, there's a data format that's even more common today, and that's called GeoJSON. GeoJSON just stands for Geographic JavaScript Object Notation. We've talked about that before. So that's what we're going to be talking about today. I did prepare a, that's from another class. I thought I had it up already. Nope. I did prepare a, if you go to the Blackboard, I did prepare a write-up on this. So you can look at what we're going to talk about today. So I've already talked over the introduction here. I mentioned using a web service or even an ArcGIS map service basically is going to draw the image on the server. And what we're going to talk about today are clients drawing GIS data. So first we need to talk about where they're going to get the data, and second, how we actually go about drawing it. And the way that that's usually done is through web mapping API. So something like Leaflet. Leaflet already has somebody's already written the JavaScript that will ingest a GeoJSON file and turn it into map data and put it on your map. Now, GeoJSON by default doesn't read KML files, but there are people who have written extensions. So if you really wanted to use a KML file, you could look up those extensions for Leaflet, and it would read KML and put it in your browser. Okay, now first off, why would we want to do this? There's basically trade-offs. There's reasons why doing this would be good, and there's reasons not to do this, to continue using a map server that's going to return a PNG. Okay. All right, and we talk about those right here. First, talk about some of the advantages. So if you don't have too much data, so the bottleneck of doing this is that the web has to transfer this data back and forth in order for you to be able to use it. Okay? And so if you have a very good internet connection, you can transfer more data through in a shorter amount of time, right? Okay. Now, images that come back from a map service, they are a certain size. And so you'll notice that when you go to a web page that has a map on it, you pan and zoom around, it might take a few seconds for your image to load. Well, the same thing happens with feature data, points, lines, and polygons. Points, lines, and polygons are text files, basically, and these text files are getting transferred back and forth on the internet. And if you have a lot of features, there's more text. And if you have less features, there's less text. And so at some point, if you have too many features, transferring that through the internet becomes difficult, okay? with an image, it doesn't matter if there's 5 features or 50 features. So if the server has drawn the picture for you, it's almost always about the same size when it transfers that information from the server to the client, because it's just a picture. It's a picture of the data. And because it's defined by the amount of rows and columns in your picture, it's almost always the same as long as your map size stays the same, okay? But if we're dealing with features, if we have more features, there's more data to press through to get through. And really, it's the number of vertices. So if you have a very complicated shape, a lot of very complicated shapes, that will take longer to get through the internet to the client. Then the client still has to read through it and symbolize it as well. So the trade-off is that although there's hardly any processing on the server side, there's a lot of, there can be a lot of information being passed to the client. So when you want to use vector layers, or you want to use vector data when you want to give the client more interactivity. But that comes at a cost that if you have too many features, then your website may get slow. So these are your 2 things that you balance: speed and interactivity. Okay. So your web browser has to read the vector data and symbolize it, but the server basically has to do very little. In fact, in some cases, you don't even need a server. You can just put the features in a separate text file. We'll talk about that. All right. Okay. Doing things like, remember last week we talked about how we might want to do something like a mouse over on a feature? Okay. A mouse over with the WMS layer is very difficult to achieve because you don't know if you've moused over until you make the request and the request comes back. Remember when I talked about that a little bit last week? However, with a feature that's on the client, there's no request that has to be made. When the feature's loaded on the client, it's there on the client. So it's very easy to do a mouse over. That's what I mean when I say it's more interactive. The client, the data is there on the client, so when you mouse over a particular feature, that feature can then display its information instantaneously. So if you don't have very many features, and when I say very many, it all depends on the factors that affect internet speed, okay? That's why I'm not giving a hard number. There's no way to say if you have 1,000 features or less, you can use vector layers. If you have 1,000 features or more, don't use vector layers. Do it using a traditional map server. There's no cutoff because it all depends on your audience and it depends on the speed of the internet connection, and that may be different in different locations. For example, if I knew that my mapping application was only going to be used in third world countries where they had the equivalent of cellular internet connection at every computer they were going to use, it might be that I could only handle using 10 to 20 features in a particular web mapping application. However, if this is an internal application that the server is going to be located somewhere on the same site, and they have a very good intranet, so if I set this up just as a mapping application for USM, I probably could handle 20,000 features pretty easily passing through the browser. So it all depends on your audience. And so oftentimes it's good to do a test. Load the amount of features up, do a test in a real scenario, and see if there's too much latency to be tolerated by your particular user. But as the numbers of features goes up, it's going to get slower, no matter what the scenario. But to know what that cutoff is, you have to be able to you have to be able to test it. Okay. So this says if you're displaying hundreds of features at a time or some complex polygons with very many vertices. So when I say 20,000 features, it's probably 20,000 points, 20,000 vertices. Browsers can get bogged down if they have to deal with too much complex graphics. Okay. Also, one of the things that you can do, and you do this beforehand. Actually, some servers are good at doing this. Okay, but in any case, one of the things that you could do is to generalize your features. In other words, if you're looking at the map of the 50 states and you have a cool application where you want them to be able to move around the map of the 50 United States, that's 50 features. And as they move over a particular feature, it gives them some information, some housing information on that state. Okay. If they're most of the time going to be looking at that map zoomed out to the full 50 states, there's really no reason to have a very detailed 50 state layer. Okay? So you can use the tools in ArcGIS or QGIS, whatever you want, to generalize the features before they get converted into GeoJSON. To generalize those features so that they draw faster. Generalize means that it works out some of the detail. I don't know if, while this is loading, I'll move on, but I don't know if you're aware, there are several features, and usually they exist for people who are doing cartographic things. Okay, we're trying to make pretty lines, but sometimes making a pretty line is to make that line more simple. All right, here's ArcGIS. I'm going to open up our toolbox and show you that there is, I don't know why it doesn't look very good on this machine, but if you go under cartography tools, you go under generalization, there's a simplified line and a simplified polygon tool that will allow you to generalize a line or generalize a polygon. And what it does is the result is a line that doesn't have as much detail, or a polygon that doesn't have as much detail. It will be a lot easier to transfer because there'll be less vertices. The number of vertices is really important, and you'll see that when I show you the GeoJSON, when I show you some GeoJSON data. Okay. All right. Okay, oops. Where's the search window? There it is. It almost smells like something's cooking up here anyway, doesn't it? So hopefully it's nothing bad. If we all of a sudden run out of the building, then you know why they're down there on the coast. Okay. It says here labeling can also be a challenge with browser-drawn graphics. And that's true. Usually you have a little trouble labeling browser-drawn graphics, but sometimes that's mitigated from the trade-off with interactivity. It's easier to let the user put his mouse over something and give you a response really quick, give the user a response really quickly as to what that is, okay? So that's the thing. And then finally, the last maybe disadvantage that I'm going to talk about here is that, and this is changing, it's getting better and better, but the symbology that's available isn't as rich, as feature rich as it is in ArcGIS. In other words, you can get really creative with the symbology that you want in ArcGIS. It's got a rich cartographic library for applying symbols, applying transparencies, and until very recently, it was hard to even get close to that in a browser. However, that's changing. It's getting better and better inside a browser, but you'll still find, and it probably always will be so, that the tools for symbolizing a feature in ArcGIS will be better, slightly more feature-rich than the ability to symbolize that in the browser. But sometimes simple is better to begin with, and so symbolizing that in the browser is not a problem, particularly if you want a simple feature. A simple way to do that. Now, different web mapping APIs have different ways to create a vector layer. And in OpenLayers, it's called one thing, but in Leaflet, the one that we're going to use, and we'll talk a little bit about how you can do it in the ESRI Leaflet next time we meet. But in Leaflet, you can either do it as a feature group, or you can actually do it as a GeoJSON layer. And I'll demonstrate that here in a second, after I talk about one more thing. One of the nice advantages to using vector layers is that if you don't ever plan on your data changing or having it change very frequently, you really don't even need a server. You can take your data, convert it into GeoJSON using a desktop GIS program, and then you can make it interactive on the client. And you just use JavaScript to do that. You don't need to make requests except for maybe for your base map. So I'll show that as part of the demonstration as well. Now, there are 3 different approaches here for retrieving your data from the server, and they don't all apply to what I just said. In other words, some of these approaches do require a server running in the background. The first one does not. Okay, the first one here is that you could write your web mapping application, in other words, your JavaScript code, you could write it with this strategy. Your strategy would be that you're going to retrieve all the data at the time the layer is loaded. In other words, when your web page loads, you retrieve all of the data that you need for your map, all of the GeoJSON, all of the points, lines, and polygons. Okay? When I say GeoJSON, it might not mean very much right now, but imagine when your page loads, somehow you load in all the points, the lines, and the polygons that you need in order to show what you need to show on your map. You load those as a separate file, or you just put them right there in your data. Okay, we'll talk about that. I'll actually demonstrate that in a second. So if you can get away with this approach, it works very well, and it makes your map work amazingly fast because everything's already loaded on the client. All they have to do is interact with the map, and every time they interact with the map, there are no more requests that are made back to the server. Okay? The drawback is that this won't really work for large amounts of data. If you have a lot of data, and again, I can't specify an exact cutoff, but you would notice this if you started to experiment. If you have a large amount of data, or even a single polygon with a lot of vertices, this approach won't work. It'll work for a lot of points. It'll work for a lot of polygons, but those polygons need to be fairly simple. Okay? It is possible to bring your browser to a screeching almost halt, like a very unresponsive browser with just a single polygon that's very complicated. So it's inappropriate for large amounts of data, and what I mean by that is a large amount of vertices in any particular vector data set, whether that's one polygon or 1,000 polygons. Okay, so that's one approach. If you can get away with it, that's great. And that approach does not require a server. You could have your data just sitting there in a text file and load that text file every time the server appears as a GeoJSON text file. The second approach here is to retrieve only the data within the current map view. So this is kind of like the way a WMS works or the way a map server works. Every time you pan or zoom around the page, you make a new request to the server and you say, this is my bounding box and I want all the features in this bounding box. Okay? And it makes a new request and returns the features. You delete all the features that you had before the pan, and you put your new features onto the map. Okay. Now the advantage to doing this is that your map only contains the number of features that are present for every pan and zoom. The disadvantage is that at every pan and zoom, you're going to make more requests to the server. So oftentimes you need to incorporate some logic. Sometimes you want to incorporate logic to maintain features that are already requested. Other times you'll want, let's say you have, I don't know, every zip code in the United States. Now, if you can imagine, if you were zoomed into like South Mississippi and you were requesting just the zip codes as you panned around the map, that might be fine because you're probably only requesting, you know, maybe 40 to 50 zip codes at a time. I don't know how many zip codes are in the, you know, the bottom southeast portion of Mississippi, the 9-county area. I don't know, it's probably 40 or 50, I'd imagine. And if you zoomed into any particular area, you'd only be getting about 40 or 50, with the exception in some areas. You know, like if you were in New York City, you'd probably have more. But what happens if you all of a sudden said zoom to the whole United States? Then a request would go out to the server that say, okay, give me all the zip codes in this bounding box. And the server would just, it wouldn't work, okay? In fact, the way ArcGIS is set up to handle that is that I think it's 10,000 records. By default, it's only going to give 10,000 records at a time. So it would just give you the first 10,000 records and stop. So you might need to put some logic in your code that says, if my map window is this big, stop making that request and just tell the user, you've got too much data on the map to display. You need to zoom in before you see some information. All right. Okay, so that's the second strategy. And think of that strategy as working a lot like a WMS, it's just returning. So the reason that you choose that strategy is if you had a lot of features, but you knew there were only going to be a small subset of those features in every view that they were looking at, and you wanted the interactivity. You wanted to have the user be able to do mouse overs and have bubble pop-ups that popped up really quick. And we'll show you what I mean by that. Sometimes it's called an infographic, the little text that pops up when you click on a button. Finally, the last strategy that I have listed down here is you want to retrieve only some of the vector features from the data set based on a filter or a query condition. So lots of times, most servers will allow you to say, okay, I only want to see these features. And this really is very similar to the one above it, but now we're querying them by attribute. We're saying, okay, I only want to see those features in Mississippi or those features in Forest County at a particular time. So the way this might be implemented in a particular web application is that the web application opens, you know, the page is drawn. The first thing the user is presented with is they're asked to choose, like let's say it's a map of the fire stations in the United States, okay? And the first thing that they might be asked to do is to choose a county. What county do you live in? So you choose the county, Lamar County, that's the county I live in, and at that point, a request is made to the server to provide me with only those fire stations in Lamar County as GeoJSON. So the GeoJSON comes back, I have the GeoJSON, or the client has the GeoJSON. Those fire stations are displayed on the map, and the map zooms to just those fire stations. And then there might be another button somewhere else that says, clear the map, go back to the beginning, and it goes back and asks for a different county, okay? So that's how that particular strategy might be implemented. So these are the three strategies, and in reality, you might see a combination of these. It's possible to see a combination between, basically this is a spatial query, and this is an attribute query. You could have both, okay? Only show me those within the United States and of a particular category. Okay. So you can see variations on those above strategies, but these are the three basic strategies. So in most cases, you would want to do this if you could, because it will allow for the most responsiveness up front. The problem with this one is that sometimes it's impossible because it makes too much data be transferred to the server at the same time. All right, so those are the three strategies. Now, we've used this term GeoJSON. I think that I've even defined it a little bit, but we haven't actually talked about what it is, okay, and how it works. It's a standard for sharing data. In other words, it describes a specific way for sharing geographic information. In fact, if you go to the web, should have put the link in the lab. I mean, in the lecture. If you go to, yeah, I think you can go to geojson.org. Geojson.org is a very simple website that just describes what GeoJSON is, okay? And we can look at how a typical GeoJSON data set looks. Okay, here's an example. A GeoJSON file contains one or more features. The features can be points, lines, or polygons. How is that different than a shapefile? Do shapefiles contain points, lines, and polygons? No, they contain points or lines or polygons. They can't contain a mixed type. So that's a unique thing about GeoJSON. GeoJSON contains many features, and those features are not necessarily, there's nothing in the specification that says that they all have to be points, or they all have to be lines, or they all have to be polygons. They can be a mix of those, okay? Now, it's written just like JSON is written. JSON, JavaScript Object Notation. It starts with a squiggly bracket. The attributes are given with the actual value of those attributes after a colon. So this is saying that the attribute, there has to be a type attribute, and then the value of that type attribute can be a feature or a feature collection. It can be one of those two. Okay, feature means a single item. A feature collection means a group of features. Okay. All right. Now every feature has two items in it. It has a geometry and it has properties. So those are the two things that every feature can have. Okay. Here's the full specification, by the way, if you're going to read it, but it's pretty complicated, or pretty lots of reading. You should be able to understand it just by looking at a few examples. All right. So every feature has a geometry and properties. Now, geometry describes the location. Now, see if it talks about this in the full specification. It does. Okay. So you can have a particular coordinate reference system attached. It is possible. Okay. you can use coordinate reference systems and specify those. However, the default behavior, and you can see that here, what do these coordinates look like they're in? Degrees, yeah, they're ranging from 0 to 90 and from 0 to 180, depending on whether they're latitude or longitude. So that's the default, and Leaflet actually handles those just fine, okay? So oftentimes it's best to convert your data that you're going to display as vector layers into latitude and longitude to be displayed as GeoJSON. They'll make it so you don't have to deal with coordinate system information. And by default, most web maps are already in what we call Web Mercator. And what's the datum for the Web Mercator? It's WGS84. So it should line up just fine. Now, if you want to start calculating things like areas and distances, you may have to do some transformations later, but we won't talk about that now. We're just talking about display purposes for now. Okay. So by default, GeoJSON uses latitude and longitude. These numbers here, you can tell that this is a latitude and longitude coordinate. So if nothing is said about the coordinate reference system, GeoJSON is assuming that you're talking about latitude, longitude, WGS84. That's what it's assuming. All right, now your properties, you have to use this keyword for your properties, but after that, your properties can be anything. And if you let's say you exported a shapefile into GeoJSON format, what would these properties be? What would we call them? What do we usually call them in a GIS file? Attributes, exactly. So if we were to export a particular file into GeoJSON, it would look like that. And in fact, we can do that. GeoServer has the ability to export any of the vector files that you have loaded into a service. You can actually export them as GeoJSON. So here is our page. Again, this won't work yet from the coast, but if you choose a drop down here under all formats, let's look at my neighborhoods. I can choose under all formats. Technically, this isn't mine, but everybody used the same neighborhoods. Oops. If you search under all formats and you go down under WFS, you can search and you can select GeoJSON. So if I hit GeoJSON here, you'll notice that what it's done is converted that shapefile, GeoServer converted that shapefile from a shapefile, and it turned it into a WFS. I mean, sorry, a GeoServer. It turned it into GeoJSON. Sorry. Now, technically, the service that did that is called a web feature server. Web feature servers are designed to serve up features rather than images. So here is our web feature server, and it's converted the data on the fly from a shapefile to a GeoJSON. So you can see that this doesn't look pretty like that other example that we showed here. Okay, this looks prettier. This looks like it's just text. But in the end, the internet doesn't care what it looks like. It just cares that it's formatted correctly. You can see this is a feature collection. It's got 57 features. And here are the 57 features. Each of the 57 features is a feature like this one was. So this is a feature. So each of these 57 features is a feature. Okay, so we can see that geometry is here. These are multi-polygons. And look at the coordinates. Those coordinates, do they look like they're in HTML, I mean, sorry, in latitude, longitude? No, those coordinates are not in latitude, longitude. Those coordinates are definitely in Web Mercator. Okay. Now, we probably could change that, making a different request. We'll try that out in a second. So here's all of our points. What do you suppose these coordinates are for? They describe what? Yeah, the vertices of the first neighborhood polygon. So if we were to look at this as back as a shapefile, we're looking at the first row. All this information all the way down to, so it starts here. Here's our first feature. And the next time we see feature ID, which is right there. Okay, so that's the first row in our shapefile. These are the points that describe the vertices. And then these right here are the properties. It's state, Pennsylvania, county, Philadelphia, city, Philadelphia, name, Elmwood. So those are the values in our attribute table. And if you look down here, so the name of this neighborhood is Elmwood. The name of the next one is Hunting Park. So that's the name of that feature. That's the name of it. That's that attribute. And I can see that it has that. Okay. One of the weaknesses is that because this is in the JSON format, it has to write these attribute names over and over and over again for every feature. That's one of the weaknesses. All right. So these are all the features for our neighborhoods layer. Now, I did point out that GeoJSON has some bulky attributes associated with it. It repeats those attribute names, but it's actually less bulky than other formats like KML. Okay, that's one reason why it's used a lot more often in today's world. Here's another example of some GeoJSON. This is some GeoJSON that we'll use today. Okay. Now this is a feature collection with only a single feature. See that single feature? These are all the vertices from the single feature. And right now this one does not have any attributes. Oh no, it does have properties. But it doesn't have any more attributes than those. And it's only one feature, Montana. All right. Let's see if there's anything else I wanted to make sure to talk about. All right. What I want to do is demonstrate using this concept of adding a GeoJSON layer to a leaflet map, okay, and how we can do that. So we're gonna use this Montana data and display it on a leaflet map. Now, in order to do this, we're going to introduce another concept. We're going to talk a little bit about a tool called jQuery. I don't even know really what jQuery stands for, but it's a library, just like the leaflet library. And what it does is it allows us to speed up our development because it does things that we commonly do. You know, if you've noticed in the last few weeks, several times I've typed in document.get element by ID, right? And when jQuery, there's a much faster way to do that. And the other advantage is it works across all browsers. So if some browser has a slightly different way of doing something, jQuery abstracts that and handles it for you, and you don't have to do that. There is a W3C schools link about jQuery that I've included, okay? But I'm going to demonstrate some of its use today. All right, and to do that, I'm going to open up Notepad++ or Notepad for those of you who are on the coast. And I'm going to talk about what this does and how it does it. Okay, now, in the past, we've already done this part. Oh, by the way, I noticed that Leaflet broke the link that we've been using for, anybody else notice that Leaflet all of a sudden stopped working? Okay, right? So we were doing something slightly, well, not the correct way before. What I had done is copied the version of Leaflet that their examples were using. Well, they changed the URL at the Leaflet help. And they don't necessarily guarantee that those examples will always work. Okay? So it was really my fault for relying on those examples. So what I've done here is changed the highlighted line, the line that's highlighted there. I've changed the reference to Leaflet to this URL. And Leaflet does guarantee that this will be maintained indefinitely. I mean, still they could break this link, but this is where this is a link that they actually want you to use to access their software. It's actually called a CDN. So it's a code repository. So use this link. If you substitute this link for both your CSS file and your jQuery, I mean, sorry, not your jQuery, your Leaflet file down here. Yeah. This file is actually already on the course website too. So this is called montana.htm. But there, that has the info. So this line and this line, modify those lines in all the previous examples, okay? Don't use the one that I cut and pasted before. This will get you to the true Leaflet that you should be using, not the version of Leaflet that I was having you use, which was changing. Okay, this will stay there. Even if they release a new version of Leaflet, they leave the CDN there for years. And then they just put a new CDN, and eventually they sunset it. So they give you years to update to the newest version of Leaflet. Okay, so those lines should be familiar to you, but we changed the code. So this is the reference to the Leaflet CSS, and this is the reference to the Leaflet JavaScript. So you need those lines of code in order to use Leaflet. Okay, the new lines of code that well, actually, there's one more line of code on here. This didn't change. This is the ESRI Leaflet. I'm not using this in any of my examples today, but I'll build on this and use that in my examples on Thursday. So I've left it in there, but we're not using any of that code today. And by the way, this is a good link. It's a CDN. You can continue to use that link. That one wasn't bad like the other one. All right, the new things that I've added are these 2 lines of JavaScript code here. All right. And these lines of code refer to that library that I was referring to, jQuery. So in order to utilize jQuery's code, you need to have these lines of code in your code. And then jQuery, we might get to this today, but we might not get to it today. We might get to this on Thursday, depends on how much time we have. But if you use jQuery's what they call UI, user interface, in other words, jQuery has some canned things that expand on what's available from HTML. One example, Lamar was asking if there's a slider bar. By default, there's no sliders in HTML. However, jQuery has a slider that you can use. And so I may demonstrate that if we get to it today. So you only need this line if you're using the jQuery UI, which is right here. Because that line will get, oops, it's basically giving you a bunch of CSS. Okay, so those are the lines that I added. Okay, one of the first things, this isn't a huge deal, but one of the first things that jQuery allows us to do is to move our script up, all of our scripts up above the body. And I like writing it better that way anyway, okay? So before we had all the scripts below the body. You know why we did that? Did I explain it before? So some browsers, when they read the page, they read it from top to bottom and they execute it in that order. And so if the elements haven't been loaded before you start referring to them, you'll get errors. It doesn't happen in every browser. It doesn't happen in Chrome, but it does happen in some browsers. And so it's safer to write the code after the body if you're referring to elements of the body in the code, okay? Well, jQuery has a way around that, okay? So jQuery works by, what jQuery does, it's kind of similar to Leaflet. Leaflet creates an object, remember, called L that you can use, L.esri, okay? Remember that? This is the kind of super overall object, the Leaflet object. If I want to interact with Leaflet, I say L dot whatever, okay? Well, jQuery's equivalent is the $, okay? And it's actually a function. So you say $, and you feed it arguments. And it has various functions, sub-functions that are associated with it. So this particular syntax, the way you read it, is that I'm asking jQuery to give me the document, and when the document is ready, then execute this function. So the reason that I can move the code, my JavaScript code, up above the here's the body down here, the HTML body elements. The reason why I can move that code up above there is that now I'm using jQuery to say, don't run any of this code that's inside the function until after the body is loaded. We're going to use jQuery pretty sparingly in this course, so you don't really need to understand exactly how everything works. But I would recommend that you at least implement this aspect of it, and then I'll demonstrate a few other examples. There is something where we'll need to use jQuery. And the reason, well, I'll explain it a little further next week, but when I want to go get JSON data that's on a different computer than the computer that served up the HTML data, that's called a cross-domain request. In other words, okay, let's say Lamar is sitting at this computer and he types in www.georgeswebmap.com and presses enter. What that does is it goes out and tries to find that URL, and then it loads the HTML associated with that URL, okay, onto Lamar's computer. It pulls it up and he sees it. Well, if anywhere in my code, if I say, well, my GeoJSON features are on this same server, everything is hunky-dory. I say, okay, well, here's my GeoJSON. In fact, I do that later here. Here's my GeoJSON data. If it's in the same file, everything's obviously great. If it's in a different file on the same server, everything's okay. However, what if my web application is showing something like earthquake data, and that earthquake data is on a server somewhere in California, because that's where the Earthquake Research Center is that I'm getting my data from. So the Earthquake Research Center in California is running a machine. Let's say they're running GeoServer, and they're running GeoServer, and it's serving up GeoJSON data. So when Lamar makes his request to my server, it loads the map, and then it makes a separate request on the map. It makes a separate request to the data, to the server in California to get the data. By default, Lamar's computer will say, I can't do that. I cannot get data from one machine and the HTML from another machine. I can't do that. It's cross-domain request. And there's a way around that, that kind of a request, but it does involve utilizing a lot of JavaScript code. And rather than rewrite and recreate all that code, we're going to use jQuery to circumvent that sort of request. But we aren't going to get to, well, first we're going to practice just using GeoJSON, and then we'll practice making GeoJSON requests to other machines. So we won't get there today, but we will get there this week. All right. Okay. So that's your introduction to jQuery. I may provide that one example I was talking about with the slider by the end of today. All right. So what does this code do? This code should look familiar. Just provide somebody provide like a 1 or 2 sentence summary of what that all that code does.
It makes your map and divides it into layers.
Yes, it makes a map. It adds 2 layers. And it adds those 2 layers. And then here, it's also, well, I didn't quite highlight that other point. So maybe I should move this up. Here, it's also adding that layer control. Say Control X, Control V. So now I could add a bunch of little comment lines. Everything above this comment line, we've done this before. Okay, we've done this. It's nothing new. I've just cut and paste that code inside the document ready jQuery function. So it's not going to execute this until the document is ready to go. So it's executed that, and it's added to the layer to control. That's a little button. You can control which layer. We've done all this. We've done this before. This is the new stuff. So really, it's not that much that I'm adding to the map. But we're going to do a few variants of this. Oops. All right. So here I've got my data. In this case, all I did was copy and paste that Montana data into this and put it all on a single line. And in fact, you don't have to do that because JavaScript isn't sensitive. So I could have put a return here, and a carriage return here, just to kind of make it look a little bit better. Maybe a carriage return there. I could have done that, and I'm pretty sure it'll be just fine because JSON and JavaScript don't care about white space. Neither does HTML, actually. So this is that Montana polygon. And then finally, I'm going to use this function called l.geojson. If you went to the Leaflet webpage, you would see the documentation for this. In fact, let's do that real quick. Leaflet, GeoJSON, and I've already been there. Okay, so here's some example. This is actually the example page. Okay, that could be very helpful for you. But you can also look at the documentation, and here's the GeoJSON layer. So here's the general the general way that it's handled. Okay. In other words, you can style. What happens is you give it the data that you want to utilize, the GeoJSON, the text. You give it the GeoJSON, and then what it does is it asks for 2 things. Style, which you can use to specify the colors that you want. And then it also says an on each feature. Okay, this is a separate function that's run for every feature that's added. And you can use this for 2 things. One, the thing that's listed there is to make the pop-up look like something that you want it to look like. The second thing that you can use this for is to add custom symbology to each feature. In other words, like let's say you want the states to be colored a different color, then you can ask for a random color and have it show up. Or you could even say, okay, well, if the value of a particular attribute is really high, I want it to be very opaque. If the value is really low, I want it to be transparent. And we'll show a few examples of that. And then finally, you're adding it to the map. So if you look at my code here, you can see that all I've done is made it so that I have a color, and then on each feature that that puts that binds a pop-up to it. So let's look at what it looks like on a map. Okay, here's my simple example. So I'm going to hit refresh here, and you can see that Montana appears on that map. Okay? If I click on Montana, I get a pop-up that says Montana. Okay, here's where I set that. If I change this to Mississippi, then if I clicked on it, it would say Mississippi. It'd be wrong, but it would still say Mississippi. Another thing I can do is, because I know that inside the properties there's a name Montana, I can change this. I can make it even better by saying, okay, this feature that gets passed into the function is this feature. So I can change this and say feature dot properties dot name, and I can ask it to show me the name of that feature as the pop-up. So now it'll say Montana. And let's say I had another feature called population. I don't know what the population of Montana is. It's got to be close to 300. Then we could say plus feature dot properties dot population, and actually I'm going to put a space here and say pop. Okay, so now it's going to report the name and the population. If I refresh this guy, I click on it, and it says Montana, population 300. I'm sure Montana has more than 300 people. I was being silly, but I have been there. There's a whole lot of buffalo when I saw them, but there's a lot of people there too. By a lot, I mean like not that many. Okay, so we could also, let's see, this is kind of difficult. Trying to find the end of that feature. Let me just hit a carriage return right here. Let's see. Okay, so here is the beginning of this feature right there. So it's nice to use Notepad++. I'm sorry y'all don't have that there, but you can see the beginning of the feature and the end of the feature. So I could add a whole nother feature here. So here's my second feature that I'm just adding. And I'll call this and instead of these other coordinates, I'm just going to delete all these coordinates right here. Here, I'll just go like this. Shift, delete. Okay, so I've got these coordinates, 1, 2, 3, 4, 5. Yeah, and I'll change this to like 90, 95, and let's see, 30, 30. Which one haven't I done yet is back to this one. This is kind of just like a interesting. I'm just showing how I can add another feature, okay, manually. In reality, when we actually do this next week, we're gonna pull using real data. I'm just showing you how you can manipulate the values here, and it'll actually update on the map. So we're gonna call this so now if I update this, I've got another fake state that I just created right here. And I named it Jim. So if I click on it, it says Jim population 700, which is pretty hard because it looks like it incorporates Houston in my fake state. It has a population slightly larger than 700. So I've got two states there. You can see that I can do this with lots of states. And when I click on a particular state, the information shown there is instantaneous. That's what's so nice about having the data loaded on the server already. So I click that, instantaneous data on the map. There's no request that's made to the server. I could also have it show some data on the side instead of showing it right there. I would have to add a function to do that. We can demonstrate that. We can demonstrate that next week. But I can put any HTML I want inside this bind pop-up. So I could put a picture in there. I could put an image tag, and that image tag would go in there. So if one of the attributes right here, if one of the attributes, in other words, one of these properties, was a link to an image that existed on the internet, when you clicked the button, it could show you that picture. So those could represent objects where you have pictures. So you really have a lot of rich functionality that you can create now once you utilize that these functions. All right, so that is the JSON. Now, one thing I mentioned in the reading is that oftentimes it's helpful to have your features, your GeoJSON in a separate file. Why? Well, because if my data was really complicated, it would take up this big chunk, and it would be distracting to scroll through all of that every time I wanted to see my data, right? It'd be hard. So since GeoJSON is JavaScript object notation, I can save this information in a separate JavaScript file. So all I need to do that is copy this, I'm going to actually cut it. Okay, I'm going to cut it out of here and put it in its own file. So I'm going to say new file, and I'm going to paste it in there. The text looks exactly the same. You still want it to say data equals. And in fact, you might want to say var, just so that it's for sure a global variable. Most browsers will handle it if you don't say var, but I'm going to write it. And then you say file, save as, and you save it usually in the same directory, maybe in a subdirectory. But here's my file that I'm working with. And I'm going to change the extension, save as type. I'm just going to put all types and I'm going to type it in. I'm going to call this, I'll call this data.js. Okay? Data.js. JS stands for JavaScript. It's another JavaScript file. I hit save. And now, how do you think I make the connection back to my same file? Where do I put JavaScript files that I want to load? Right here, right? I put them right here. So this is a link to a JavaScript file. This is a link to another JavaScript file. These are links to two other JavaScript files. This isn't any different. It's just another JavaScript file. So I can just copy and paste this text. And all I have to do is change the reference. Now, where's my JavaScript file saved? I didn't put it in any subdirectory or anything, so it's just data.js. So now it's going to load that JavaScript file, that other JavaScript file. When the page loads, it will load that other file. And so that when it finally gets down here, and it won't execute this till the document's ready. So it'll be done loading that other data. And it will display it on the map. And it'll look just the same. So if I hit refresh again, it looks the same. But now it's loading that file from a separate file. Just to show you that it's actually loading it from that file, I'm going to make a change here. I'm going to go into data.json, and I'm going to make this 33 and reload the page. And you can see that it trimmed that polygon there. Okay, so it is accessing the data in this file from this file. This isn't any different than when we first started learning, and I showed you how to reference an image from a different file, right? This is, instead of referencing an image, we're just referencing data. Technically, we're referencing code that's in a separate file. Does that make sense? So our code is in a different file. That way, we don't have to worry about scrolling through a large set of data. Well, the other thing here that the trade-off here is that if somebody was to read your code, they might wonder, where did this variable get created? This variable called data. Where did you create that? I don't see where you created that anywhere in your file. To be helpful, I did name it the same thing, so that people could maybe see where it came from. But that's how I did that. All right. I can play with a few things here. I can play with the colors. Obviously, here I'm going to make it a different color. There's changing the colors of the data. Remember, the first two letters represent the red, second two letters represent the green, and the third two colors represent the amount of blue. And I'm not very good at mixing colors myself, so you can always go to an HTML color picker, and if you really want to pick out certain colors, I think I've shown this before. So I like this dark blue color. So here's my selected color. That's the code for it. And I just copy this into my thing. And now my polygons will be that color wherever they are. They'll be that dark blue. Okay. By default, there's a transparency associated with it. Okay. These are just web styles. So I can set the opacity to 1 and see if that changes it. I don't know if that'll work. Oh, maybe I didn't spell it right. I guess I did spell it right. I don't want that semicolon there. Let's see. That's probably an example here. Some reason. Mice are nice. Let's see if we can look in the documentation. It's always good to look in there. Options, style. So that's only the path. It does say opacity. I don't know why it's not updating opacity. I'll have to find that out. Because by default, it is assigning some level of opacity to it. It's okay if it's semi-transparent, but sometimes you'd want it not to be as transparent or to be more transparent. So I could even think of cases where you'd want it to be completely opaque. In other words, where you'd want it to be, completely transparent, where you'd want it only to be if the user clicked, but you wouldn't actually want to show a boundary. All right. All right, so we don't have much time, but maybe we do have enough time just to demonstrate the other example that I have. Let's see, what did I call it? I think I just called it vector layers. Okay, so this example I'll post up today on the web page, and it does a lot of the same things. It doesn't actually show any vector layers, and maybe we can build off this next week. What it does do is it demonstrates the use of another jQuery function called a slider. So I just have this example up. If you want to use it, you can. Vector. It's not required that you utilize any jQuery widgets for your final project, but it is available if you want to. Okay, so seems I've messed up a little bit here. Let me try. Yeah, there we go. So all this does, actually, I do want to see the console. So this doesn't do anything at all exciting yet. Where's the job? Developer tools. Okay, so I've got my console open. All this does is it creates a map, and then it loads this new widget for you at the bottom of the page, and this is a slider. And I haven't done anything else fancy. I could have put, high, medium, low on the slider, all sorts of things, but I added a slider. And when I change the values in the slider, it tells me what that value was. And the value right now is 59. By default, it goes from 0 to 100. So that's 0. See how it reported a value of 0? If I bring it all the way out here, a value of 100. If I put it somewhere in the middle, it's going to be a value right around 50. It's 49. Okay. There's all sorts of things that you can do to modify the amount of stops. Like you could have it go from 1 to 10 or from from 0 to 20 or from 0 to 5. And then you could add little HTML elements at the bottom that would report high, medium, low, whatever you wanted to write, okay? So this is the code, all the code that was necessary for me to create the slider and to report the value when you moved it. So if you wanted to make the map do something, you could put that code right here. Put code to modify map here. All right, so that's where you put your code to modify your map, but based on a value. Like it might be a layer number. So you could have 5 layers in your ArcGIS service. And as they moved up, you're just changing which layer is shown, swapping out one layer for another using the examples we talked about last week. And each layer might represent a different year. So you'd be sliding on a different year. If you did that for a final project, that's a cool example of a final project. Even if you just did it as radio buttons, didn't do it as a slider, it'd be a great example. Okay, well let's look at what the jQuery is doing here. Okay, so this is jQuery. jQuery is doing that portion of it. So this line of code simply creates a slider. And what it does is it says, okay, find the ID slider somewhere in my code. So I go down here and you can see there's an ID slider. Make that div a slider, okay? And I could, by the way, I make the page element have its width right here. So I can make a narrower slider or a longer slider right there. So that's all this line of code does. So instead of, one of the things jQuery can do is it uses this part right here. If I got rid of that part, this line of code right here is equivalent to saying document get element by ID, and I don't have to worry about what's capitalized and what's not, and then saying slider. Okay. This line of code is equivalent to that, and I don't have to worry about spelling or anything. So that's one thing that jQuery does, is it allows you to get elements more quickly based on their IDs. You can also, we probably won't get to all this in this class, but you can also use jQuery to jQuery to find elements by a particular style. Like you can say, give me all the elements that are using, text that looks like this, or give me all the elements that are a particular class. Give me all the elements that are radio buttons. Give me all the elements that are radio buttons that are inside of this particular div. So you can get really specific. So like, let's say you're designing it so that you have one set of radio buttons that's determining the year, another set of radio buttons that's determining like the category of a storm. So you want to look at what a category storm would look like in 2200 versus a category 4 storm in 2012. You could have like, what is that? That would be 16 different layers on the server. And so every combination would be a different layer. So you'd have to write the logic that said, okay, well, if this radio button and this radio button were selected, turn on this layer on the server. If this one and this one are selected, turn on a different layer. Well, you could do that in plain old JavaScript, but it would be more quick to do it in jQuery. And again, it wouldn't be extremely more quick. It's not probably not proper English. It wouldn't be extremely quicker, but it would be quicker. And as you're writing more and more complicated applications, it becomes more of an advantage. So that's why I say you don't have to use jQuery, but if you spend some time getting to know it, it can help your web development go faster. So sometimes I'll show examples using both jQuery and regular. Obviously, if you want a slider, you got to use some library, or you have to write all the code to do this yourself. Okay. If you think about how much code is involved in that, So they're dynamically placing this box, making it a certain width. Then they're dynamically placing this box, and there's an an on click, an on drag. There's a bunch of functions that they've written. The code that creates the slider, I wouldn't be surprised if it's a couple hundred lines of code that creates that slider. And so it's nice to be able to borrow that code that creates a slider. And by the way, jQuery is an open source piece of software. There's no fee to use jQuery. It's free to use. There's a competing competing open source project called Dojo, and it does a lot of the same things, but I probably won't have many examples. I probably won't use examples from that one. jQuery is used a lot more. However, Dojo is used by ESRI a lot. But I think Dojo is, you guys might be thinking right now, well, jQuery looks a little bit complicated. Dojo is a lot more complicated in its implementation. So there's a little bit steeper learning curve to get used to Dojo than there is jQuery. So I think it's good to start off with jQuery. So this is called the selector, by the way. So if I have a pound sign, I'm asking for an ID. If I have a dot, I'm asking for a class. So those are the differences there. So here I'd say I'm looking for everything that is class slider, I want to turn it into a slider. Okay. Here I'm saying I'm looking for something with an ID slider, and I want that to be a slider. And then I'm looking for the slider again. Actually, I've repeated some lines of code. This line of code doesn't even need to be here. Sorry. You could do that in two separate lines of code, but it makes a lot more sense to just do it in one line of code. So that line of code creates the slider and then adds a function to its change event. By the way, here's the web page for jQuery. If I just type in jQuery slider, that's how I would get to the help for the slider. There's an example. Here's some code that might help. Oh, sorry, if you get the API documentation, that is the code that might help. So these are all the events. So you got change, which is the one I used, create, slide, start and stop. Those are all events. There's things like range, step, value. Like let's change the step on mine to 10. Now, if I load up my page again, I lost where I put it. This is it. If I load up that page again, now I can't choose anything but every 10 values. So see how it says 20. If I go up, it says 30. If I go up again, it says 40. Those are those values. Okay. I could use this slider like in the example where I had the circle and we had the circle grow. If I went back to that example, I could put a slider there instead of having a input value. Exactly. Thanks. All right. So I'll open this up and leaflet example. Was that the first one? Initial center. Yeah, so let's call this, let's go back to my vector layers. I'm going to save this as slider circle. Okay. Then I'll go back over to this leaflet example. And I'm going to just kind of fly by the seat of my pants here. Initial center. Change this. And then change, no, don't want to change that. I want to change this though. Leaflet. No, yeah. Do that. So I'm just taking this data like that, and I'm gonna keep making that mistake. I'm gonna keep it up with this data. Not that it matters. I'm just gonna keep this separately from this. So this is gonna pop up, and then finally, I have my update button. But I don't want to do that. Okay, I'm going to take this. This is the code that actually changes the radius of the map. And I'm going to, of the thing. I'm going to copy and put that inside here. And say user distance now. This is going to be UI.value. All right. I don't even know if it's going to work. Slider circle. Slider circle.html. Okay, so I've got my circle here that is around Walker Science Building. If I slide this, yep, it works exactly the way I thought it was going to work. So now, as I slide this, I get a value that goes bigger or smaller. I'll post this as an example too. So I can use the sliders to provide interactivity to the map. So all I did was kind of combine two of the examples. I can put any code I want in this function. So I can use it to swap layers out, to add or put in new layers. Okay, I can use it to modify the circle in this case. I can use it for all sorts of different things. We've only shown you the slider. Okay, there's so many widgets that are available. I can't show you every widget in class, but if you decide, hey, I have a particular widget in mind. I've seen this on other web pages. I can steer you to the help and even show you a demonstration of how to use that particular widget. There's very complex widgets, like there's date pickers, there's time pickers, there's color pickers. There's also more simple widgets. There's buttons. You don't really need to use the buttons, but you can use the jQuery buttons if you want to. There's drop-down buttons, like there's like a list to choose from. Those kinds of things. It's kind of similar to radio buttons. So if you have the desire to use any of those rather than using the simple HTML, it's fine. Like I said, you don't have to use it for your final project, but you can. Okay. All right. So I'll upload those. As far as an assignment today, there's not an assignment yet. So your assignment will be to load in some GeoJSON data from either one of your servers, so one of the servers that we created, or I'll give you some examples of some data set, because lots of people share their data as GeoJSON. Like, for example, the earthquake example I gave you is real. So your assignment will be to load some data from a server onto a web page, but it won't be due from today. It'll be due from Thursday, because I'm still going to show some more examples of how to do that on Thursday. All right. Yeah, go ahead.
It doesn't necessarily have to be from the server that you have on XAML, right?
No, it does not have to be from the Geo server that we have up here. I will show that as an example. It could be from almost all GeoServers have that enabled. So I'll give some examples of some GeoServers that are external to this one, so that you can access them from down there. I'll give some examples of other GeoServers. We'll also cover how to do basically the same thing with an ArcGIS server, which they have their own. They don't use GeoJSON. They have their own standard for sharing vector data. It is still a JSON format, but it's technically not GeoJSON because that's a specific open format. It's referred to as ArcGIS featured JSON or something. But you can, I forget how ESRI calls it, but we'll show those examples. So on Thursday, we'll show handling data from external servers, including GeoJSON and ArcGIS JSON. And then I'll give you some examples of where to look for services that you can implement. So that's what the homework will be, showing data. Doesn't necessarily have to be your data. In fact, even for the final project, it doesn't have to be data that you publish. You can publish it, but you don't have to. All right. Any other questions? I do want to do to come down to the coast. Would next week be okay? Will you guys be around next week?
Yes.
Okay. Now I can come on Tuesday or Thursday. The thing is, if I come on a Tuesday, I have to leave right after class. I don't know if you want me to come on, because I teach a night class up here at 5 o'clock, and so
that's fine.
Okay, so I'll come down on a Tuesday, and then I'll just leave right after class to come up here. Okay, so it'll probably be a week from today then.
Okay.
All right. If y'all have any questions, I'm actually going to be working around here. I may be in the lab, I may be in my office. I'm trying to get some software on these computers before my night class, so I'll be around. I'm going to stop the video and upload those examples though. So I'll be in my office for at least the next 10, 15 minutes doing that. I procrastinated doing it last week. Now remember, if I forget to upload the lecture, you can always go to Google Plus and go to ghy.gis, and that's pretty much the only thing that's posted to Google Plus is to that identity's Google Plus are these lectures. So you can, I'll show you what I mean by that. So you could go to here, go to Google Plus, and then if you search Google Plus and you just type in ghy.gis, it is that, right? You might even be able to search George Raber, but you have to remember there's two George Rabers, because there's graber@gmail.com. That doesn't have the lectures. And then there's, so if I search people and pages, maybe, I've never actually tried to search this, but you should be able to get to it from Google Plus if I forget to upload the lecture. But anyway, I don't know exactly how to do that, but I will upload a link to the today's lecture right now before I forget. I'm going to hit stop broadcast. So last week's lecture is there, but I didn't put the link to it till today. All right, I'm going to hit